Why do you look the way you do? Why is your nose shaped like that? Your skin, that particular shade, and your hair, that specific texture. None of this is a coincidence. It's the result of millions of years of evolution, interbreeding between species, mutations, and nature's errors that became fixed in your DNA. Within you live traces of extinct humans: Neanderthals, Denisovans, Cro-Magnons. Some of your features are useful, others are useless, and some might even make your life harder. But all of them are heritage, and you have no idea how deeply rooted it is inside you. Watch till the end, and you'll learn why your face is a revelation from prehistory, and which hidden genes are controlling you right now. When you look at your face in the mirror, you're not just seeing a modern human. Some of your features aren't entirely yours. They're tens of thousands of years older. You may have inherited them from Homo neanderthalensis, a broad nasal bridge, pronounced brow ridges, a strong lower jaw, a short chin, deep-set eye sockets, a heavy forehead. All of these are classic traits of the Neanderthal skull. You might not have all of them at once, but some still appear in people all over the world. When Neanderthals left Africa and settled in Europe, they adapted to the harsh climate. Their skulls were larger, their facial bones thicker. They needed to warm the air they breathed, protect their faces from the cold, and retain heat. That's why they had enlarged nasal cavities and a prominent frontal ridge. These weren't just anatomical quirks. They were reflections of survival conditions. And when Homo sapiens began to interbreed with Neanderthals, those traits entered our gene pool. You might have a narrow chin and a broad jaw, a typical blend of modern and Neanderthal features. Some people still carry these traits in a pure form. For example, a prominent sloping forehead or wide nostrils, ancient adaptations that are no longer necessary, but remain. Even cheekbone shape can be inherited. Neanderthals had forward-projecting zygomatic bones, and some modern people still have facial structures that give them a heavy look. Interestingly, genetic studies confirm that Europeans and Asians carry on average between 1% to 2% Neanderthal DNA. In some regions, the percentage is even higher. That means the likelihood that you carry at least one Neanderthal feature on your face is very high. And it's not just about appearance. These genes can influence bone structure, nose shape, and even your bite. It's possible that your dental problems are echoes of a prehistoric past. So next time you look in the mirror, remember, in that face lives someone who once walked through a glacial forest 40,000 years ago, and you probably had no idea how much of you comes not from modern life, but from those who disappeared, leaving behind their signature written in your bones. The earliest humans living in Africa had dark skin, rich in melanin. It was a shield against the scorching sun, protecting folate in the blood, preventing sunburn, and reducing the risk of skin cancer. This level of pigmentation was perfectly suited for life under the equatorial sun. But when part of the population migrated northward, everything changed. There was less sunlight, and dark skin became a disadvantage. It blocked ultraviolet rays too well, leading to a deficiency in vitamin D. Nature's response: mutations that lighten the skin. These mutations were preserved in those who survived, and now most people in Europe and Northern Asia descend from those whose skin lost pigment. Here's the first effect. Light skin in modern humans isn't just paler, it's thinner, more sensitive, more prone to sunburn, and less effective at blocking UV radiation. Many people of European descent have skin that reddens easily, is prone to rosacea, and ages faster in the sun. This is a direct result of a weakened melanin barrier, advantageous in foggy climates and short daylight hours, but leaving us vulnerable today. Among Asian populations, the skin also became lighter, but developed different traits. It became denser with more stable pigmentation. This was an adaptation to a temperate climate, neither hot nor dark. Such skin retains moisture better and ages more slowly, but is often prone to hyperpigmentation and breakouts, especially during climate shifts. In African populations, the skin retained its dense structure and melanin richness, which offers resistance to sunlight, but hinders vitamin D synthesis when moving north. Many descendants experience chronic vitamin D deficiency and related issues, bone weakness, fatigue, hormonal imbalances. If you have mixed ancestry, your skin may behave unpredictably. For example, oiliness, characteristic of equatorial populations, might combine with thinness and paleness inherited from northern ancestors. Or your skin might appear dark, but still accumulate vitamin D deficiency. Or it might seem dense, but burn easily. This isn't a cosmetic flaw. It's a conflict of ancient adaptations. Your skin today isn't your skin. It's a collage of genes that survived in different corners of the world. And every pimple, burn, or peeling patch isn't a mistake. It's a reminder. Your appearance is the product of thousands of years of survival, compromise, and migration. For ancient humans, especially Neanderthals, the face wasn't just a surface, but a tool. Their skulls were shaped not by aesthetics, but by necessity, constant chewing of tough food, using teeth as tools, injuries from fights, falls, and hunting. This pressure shaped their anatomy. Prominent brow ridges, thick forehead bones, powerful jaws, and wide nasal passages. The face was their point of contact with reality. As living conditions changed, so did the skull, but not instantly. Many modern people inherited traits that once saved lives, but now cause problems. For example, some men still have prominent brow ridges, not as a sign of strength, but as a genetic echo. A shortened facial region can lead to overcrowded teeth, but that same feature makes the face appear softer compared to ancient ancestors. One of the least noticeable, yet most ancient inheritances is the ratio of cheekbone width to face length. In Neanderthals, this allowed the head to remain stable under heavy strain and gave the face an angular, primitive look. This ratio still exists in some people today and even contributes to ethnic identity. Even the structure of the eye sockets tells a story. Neanderthals had deep-set eyes, protecting them from bright light and injury. This trait still appears today, especially in people with northern lineage. A flat nasal bridge and short nose might be inherited from ancestors who survived in extreme cold. What's especially interesting is that the brain began evolving faster than the skull could adapt. As a result, new skull shapes emerged: higher foreheads, asymmetry, and unusual curves. This isn't a flaw, but an adaptation. The skull had to evolve rapidly to accommodate an increasingly complex brain. So, if you've ever thought you have a weird forehead, a heavy gaze, or a bad bite, it's not a mistake. These are imprints of survival, of evolutionary pressure, of environments where your ancestors fought, ate, froze, and endured. All of that is still visible in the shape of your face. Your hair carries far more meaning than just its color or style. Its structure, thickness, and shape are direct inheritances from the environments in which your ancestors lived. If you have straight, thick, and coarse hair, it's not just genetics, but a mark of adaptation to cold climates. Such hair lies flatter against the scalp, creating added insulation and retaining warmth. Neanderthals exhibited this kind of hair structure, compact, heavy, slow-growing, which helped conserve energy in frigid conditions. Curly, springy hair represents a different kind of adaptation. It better protects the head from overheating and sun exposure. The spiral shape creates an air buffer and disperses heat. This type of hair is most common among descendants of early humans from Africa. It's not a fashion, it's an evolutionary solution. Now to the less obvious. Thin, sparse hair is an inherited compromise. In a time when regulating body temperature was more critical than aesthetics, some ancestors began to lose dense body hair, but not uniformly. Some lost it from the head, others from the body. That's how modern variations arose. Male baldness, low hairlines, a tendency to lose hair. It's not a defect, but the result of a complex process. When thick coverage became unnecessary, the body reallocated resources. Hair color is another ancient marker. Lighter shades, including red, appeared more often in areas with low solar activity. Reduced melanin levels were compensated by better vitamin D synthesis. Red hair and pale skin are strongly associated with Neanderthal ancestry. The MC1R gene, responsible for red pigment, came from them. Carriers of this gene are often more sensitive to pain and have a higher risk of sunburn. Yet another case of an ancient adaptation causing modern vulnerability. If you've noticed uneven hair growth, early graying, or brittleness, it's not just a quirk. It's the imprint of a long transition from dense fur to partial baldness. Hair is an evolutionary chronicle that doesn't need words. It shows who your ancestors were, where they lived, and how they survived their climate. The shape of your skull isn't random and has nothing to do with fashion. It's an archive of adaptations shaped by climate, food, breathing, and even the ways your ancestors communicated. In Homo sapiens, the skull became more rounded and taller, the forehead vertical, the jaw less pronounced. Why? Because food became softer, tools replaced teeth, and speech, the main survival tool, required more space for the frontal cortex. Now compare that to Neanderthals. Their foreheads sloped back, brow ridges were massive, jaws were strong. They needed more power for chewing and more protection for the face against impacts and cold. But these aren't just museum relics. Parts of these features still remain in us. If you have a prominent occiput, a strong chin, a low forehead, or a wide nose, these are echoes of the Ice Age, where only those who could take a hit and tear through sinewy meat survived. Some facial features are linked not to beauty, but to ventilation and air warming. Wide nasal passages were a response to cold climates, where air needed to be warmed before entering the lungs. In contrast, descendants of tropical populations tend to have narrower noses, which help cool and humidify air. Even the size of the eye sockets isn't accidental. Neanderthals had larger sockets, necessary for survival in dimly lit caves in long winters. If your eyes are deep set, that's not a feature. It's a remnant of an ancient mechanism for coping with low light. The shape of your head and jaw is also shaped by diet changes. As food became soft and cooked, the bones changed. Less chewing meant less bone growth. That's why modern people often deal with crowded teeth and bite issues. The skull shrank faster than the jaw, and now there's less space for teeth. All of this isn't just anthropology. It's a mirror. You might look in it every day without realizing that you're not just seeing yourself, but also the ancient world from which your bones, breath, voice, and face emerged. Teeth are not just bones. They are evolutionary archives. When scientists study the teeth of ancient people, they gain insight into diet, lifestyle, stress levels, disease, and even age at death. And the condition of your teeth today is largely determined by how your distant ancestors lived. Neanderthals and other archaic humans had massive jaws with wide arches and large gaps between teeth. They needed this because their food didn't require chewing. It needed to be crushed and torn apart. Raw meat, sinew, roots, bone marrow. This was not soft cuisine. To survive, they needed extremely strong jaw structures. So they had powerful molars, thick enamel, and large pulp chambers. And no crowding. Their teeth were spaced well, distributing force efficiently. Things began to change with Homo sapiens, especially with the rise of agriculture. People started eating cooked, ground, warm food. Gradually, the jaw shrank because less chewing was required. But teeth, encoded by the old evolutionary blueprint, remained large. The result: crowding, malocclusion, wisdom teeth with no space. You visit the orthodontist because your mouth is no longer adapted to the old tooth size. Interestingly, baby teeth in ancient people also emerged later. Today, children's teeth erupt early, possibly due to changes in diet and hormones. But the basic plan, 20 baby teeth, 32 permanent ones, is inherited from a time when human life was completely different. Even toothaches aren't random. They result from a mismatch between genetic heritage and modern environment. Our ancestors rarely had cavities. Streptococcus mutans, the bacterium that causes them, spread widely only after sugar became common. But enamel, tubule structure, and inflammation responses haven't changed. Your tooth hurts not because it's weak, but because it's made for a different world. So if you've got bite problems, crowded wisdom teeth, but can still crack nuts or open bottles with your teeth, know that you're carrying in your mouth a memory of those who lived tens of thousands of years ago. Your dental problems might also be echoes of a prehistoric past. Neanderthals had brains that were not smaller, but often larger in volume than those of Homo sapiens, averaging around 1,500 to 1,600 cubic centimeters. But the distribution of that volume was different. Their occipital lobe, responsible for vision, and the sensory motor areas were especially developed. This matched their way of life. They lived in environments where visual acuity, coordination, manual work, and instant reactions were crucial. Moreover, their daily lives didn't require abstract thinking, relying more on skills, strength, and repetitive actions. As civilization progressed, these parameters became less of a priority. However, some modern humans retain inherited neuroanatomical traits that influence behavior. For example, a tendency toward practical thinking, focus on detail, mechanical memory, and repetition. This is neither good nor bad. It's a form of cognitive specialization, the same kind that was useful in an Ice Age forest and now shows up as a love for hands-on work, craftsmanship, tactile learning, and visual instruction. Studies show that up to 60% of the Eurasian population inherited certain genes that affect the formation of dopamine receptors. This may increase anxiety, heighten stress response, and reduce cognitive flexibility. But those same traits, endurance, persistence, and concentration, were critically important in the past. That's why they still persist today. You may not question why you find it hard to switch tasks, or why you understand diagrams more easily than reading instructions. But this may be an echo of an ancient brain that, for millions of years, didn't need theory. It needed precise action. And although today you sit at a computer, your way of thinking may still be shaped by a glacial reality. You might think that mental disorders are a modern problem, caused by stress, technology, or information overload. But in reality, many of these conditions have deep roots in prehistoric times. We inherited not only physical traits from Neanderthals and other ancient species, but also genes linked to brain neurochemistry, emotional regulation, and susceptibility to mental disorders. These mutations arose in environments where high anxiety, hypersensitivity, or heightened threat response were adaptive. They helped people survive. For example, scientists have discovered that certain variants of the SLC6A4 gene, which controls serotonin transport, were passed to us from Neanderthals. These are linked to lower stress resilience, a predisposition to depression, and heightened emotional reactions. In an era when danger required instant reaction, this environmental sensitivity was an advantage. But in the modern world, with its constant noise, social pressure, and competition, those same traits can become sources of suffering. Neanderthals also had gene variants affecting circadian rhythms, the body's internal clock. Some modern humans inherited these forms and are now more prone to sleep disorders, seasonal depression, and difficulty adapting to shifts between night and day. In the Ice Age, where night could last for weeks, such adaptations were normal. Today, they may manifest as chronic insomnia or disrupted biorhythms. Research has also shown that Neanderthal genes play a role in forming the autistic spectrum. Specifically, traits like altered sensory processing, repetitive behavior, and weak social intuition. All of this could have been useful in hunting, manual labor, and intense task focus, but becomes a disadvantage in a world where communication and social flexibility are crucial. Moreover, studies from the 2020s revealed a link between Neanderthal DNA variants and predisposition to schizophrenia and bipolar disorder. This doesn't mean ancient humans were mentally ill in the modern sense, but their brains worked differently, with other priorities, neurotransmitter balances, and environmental responses. Today, this may appear as mood instability, attention problems, or increased impulsivity. Finally, we must consider the role of dopamine. Some dopamine receptor types inherited from ancient humans influence motivation, susceptibility to addiction, and novelty-seeking behavior. In the hunter's world, this helped locate new food sources and resources. In the modern world, it may lead to overeating, internet addiction, compulsive gaming, or substance abuse. This is why mental traits aren't flaws. They're versions of evolutionary adaptation. What once helped someone survive might now get in the way of daily life. Your anxiety, sensitivity, or social withdrawal may not be weakness, but echoes of a world where a single noise could mean death. Understanding this helps not only to accept yourself, but to recognize the imprint of thousands of years of survival. The immune system of modern humans is not a product of civilization. It is a relic of ancient wars, once fought by Neanderthals, Denisovans, and their peers. Everything that entered their bodies, bacteria, viruses, parasites, rotting food, wounds from hunting, demanded immediate and powerful immune responses. The ones who survived were those whose immune systems were the most aggressive and fast-reacting. As a result, we inherited not only protection, but also a tendency toward dangerous hyperreactivity. Fragments of ancient genetic code responsible for recognizing and destroying pathogens still live in us. For example, outside of Africa, many people carry Neanderthal versions of the TLR, 6TLR, 1TLR, 10-gene cluster, which enhances immune response to bacteria. In cave environments full of injuries, this saved lives. Today, it increases the risk of allergies and autoimmune diseases. What once defended us now attacks our own cells. Another example is the STAT2 gene from the Denisovans. It boosted resistance to viruses, particularly RNA viruses, dangerous in the Asian climate. Modern carriers of this gene handle some infections better, but may also be more prone to inflammatory reactions and immune dysregulation. Neanderthals also passed down a stronger OAS1 gene, which triggers faster antiviral responses. It still helps launch defenses against viruses, but also increases the likelihood of cytokine storms, dangerous overreactions of the immune system. According to geneticists, this may affect how some people respond to severe viral diseases, including COVID-19. Even the risk of type 2 diabetes partly traces back to prehistory. Some inherited genes regulating metabolism once helped store fat and survive famine. But in a world of abundance, they now raise the risk of metabolic disorders and chronic inflammation. Immunity isn't just protection. It's a compromise between survival and self-destruction. Inside, you still lives an ancient hunter whose body was ready for anything. Bear claw wounds, insect bites, or spoiled meat. That hunter still fights for you. But in a world where the enemies have changed and the weapons too often turn inward, many modern mental disorders are not malfunctions. They are side effects of evolution. Our brain was shaped under conditions that no longer exist. The shift in those conditions turned some ancient traits into harmful ones, even though they once helped us survive. Take anxiety, for example. In the past, it saved lives. A person who noticed danger faster was less likely to become prey. Their children inherited that vigilance. Today, the same traits lead to chronic stress, insomnia, and panic attacks. Fear hasn't disappeared. It just no longer knows what to react to. There's no saber-toothed tiger, but there's a boss, a loan, and the news. Depression is another example. Scientists suggest that the tendency toward depressive states may have been a form of energy conservation. If a person was sick, injured, or starving, detachment and lethargy helped preserve strength. Today, that same reaction often activates without a real cause, because the brain doesn't distinguish physical threats from social ones. Some genetic variants linked to mental disorders came from Neanderthals. For instance, a mutation that increases pain sensitivity is also associated with a higher risk of depression. This doesn't mean Neanderthals were prone to depression, but their nervous systems worked differently, and parts of those systems are now built into our brains. Modern carriers of such genes more often report headaches, migraines, and chronic tension. Seasonal affective disorder is another ancient mechanism. It is especially common among people with northern ancestry. In an era when life depended on light, decreased winter activity conserved energy. Today, it turns into apathy and a reluctance to get out of bed. The same goes for insomnia. In the past, staying alert at night helped protect the camp. Now, it causes exhaustion and chronic fatigue. Even paranoia may have evolutionary roots. In small groups, too much trust was dangerous. Distrustful individuals survived longer. Today, this shows up as thought disorders and anxious suspicion. What used to be useful caution has become a debilitating symptom. We are not built for silence, peace, or stability. Our brain is a threat detection machine. And when it finds no threats, it creates them. That's why the ancient genes that once gave us a chance to survive now make us vulnerable. When people say, "I'm just like this because I was born this way," they rarely consider how far back that "this" truly goes. But your nose, skin color, height, tendency toward allergies, or how you handle stress, all of it is the outcome of millions of years of selection, randomness, and survival. Behind every one of your traits is a chain of ancestors, each passing down a small part of themselves. The shape of your skull is not just anatomy, it's the mark of an evolutionary battle between brain and jaw. The higher the forehead, the more space for the frontal cortex, the region for planning and self-control. But at some point, the jaw shrank and the brain grew, leading to round skulls that differ from the elongated shapes of Neanderthals. Your skin is the result of adaptation to sunlight. If your ancestors live near the equator, it is denser, darker, richer in melanin. If they lived in the far north, it is lighter to produce vitamin D in low light conditions. Today, you can move anywhere, but your skin still remembers the region where your ancestors survived. Your nose is not just a facial feature, it's a filter, a heater, and a humidifier. A humid climate produced flat, wide noses. Cold and dry air led to narrow, long ones. Every contour of your face is not about beauty. It's nature's engineering for specific environments. Even your hair isn't about fashion. It's biology. Curly hair disperses heat in hot climates. Straight hair retains warmth longer in cold ones. Skin oiliness, blood clotting, bone density, pain sensitivity. You didn't choose any of it, but you carry within you millions of decisions made long before you were born. Your body, your personality, even your weaknesses. They're not individual glitches. They're parts of a system that's been working for a long time. Some parts are outdated, others still matter, but not one of them appeared by accident. Everything has a root. You're not just a set of genes. You're an archive. Inside, you live Cro-Magnons, Neanderthals, Denisovans, hunters, gatherers, survivors of famine, frost, injuries, and disease. The way you look and feel today is the result of thousands of years of struggle. It's not a flaw. It's evolution. And maybe when you look in the mirror, you don't just see yourself. You see everyone who made you possible.